All right, number 2, we have ABCD part. It wants us to find the prime factorization of the following numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're multiplying all those together. Okay, so prime numbers start with the number 2. There's a list in the text. 2, 3, 5, 7, 11, 13, and so on. Okay, so we're going to break the numbers that are not prime into primes, and then we're going to combine like terms. So 2 from this list is already prime, as is 3. 4 we can write as 2 times 2. Okay, 2 is prime, so we'll have 4 there. 5 is prime. 6 we can write as 2 times 3. 7 is prime. 8, 2 times 4, and 4 is 2 times 2, so we'll write 3 2's here. 2 times 2 times 2, that's for 8. If we did a factor tree, we would do 8 and then break it down to 2 and 4, and that 4 will go to 2 and 2. So that's how we're getting those 3 2's. And then 9, we'll multiply 3 times 3. 10, we can rewrite as 2 times 5, and 11 is prime. Okay, so this is our list. I didn't write 1 because anytime you multiply by 1, you get the other number, so multiplying by 1 will not change anything. And now all we need to do is count and list these numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8 2's. So we will write 2 to the 8th power. Okay. I'm only seeing one answer choice with that. So just based on that one, we would get C. Well, let's finish it out. 3's, we have 1, 2, 3, 4. So we have now 3 to the 4th. And then we'll count the number of 5's. 1 here, 2 here. So we will have a 5 squared. We have 1 7 and 1 11. Okay, so it looks like this would be the prime factorization, and everything matches. Okay, so we have 55 to the 5th power. So we're going to rewrite this 55 as 5 times 11. And as property of exponents go, if these things are being multiplied, we can pretty much distribute each of these a power of 5. 5 and 11, 5 and 11 are prime. So we'd have a 5 to the 5th and an 11 to the 5th. And that would be the same as 55 to the 5th. And then we have 65, which we can rewrite as 5 times 13. And then we have 4 to the 15th, okay, which we're going to rewrite 4 as 2 times 2. Or we can say 2 squared, that would be better. And it is raised to the 15th. Okay, so properties of exponents says 2 exponents power to a power you will multiply. So we will write this as 2, and this 2 will get multiplied times 15 and give us 30. So now I'm just going to combine this additional 5 with this one. So we will have, let me write the 2 first. 2 to the 30th, okay, from this term. We have 5 to the 5th, plus this one will give us 5 to the 6th. Okay, so we've used that, We have 11 to the 5th, and then 13. So we want which is giving us 2 to the 30th, 5 to the 6th, 11 to the 5th, and 13. Okay, 227, whole number. We're actually going to divide this one ourselves, if it will break down. 277. Okay, so let's look at some of our rules of divisibility. If it ends in an even number, it's divisible by 2, which this is not. If we add up these digits, 7 and 7 is 14, 15, 16. So I'll look at that number. If it's divisible by 3, this number is divisible by 3. It's not. Divisible by 4 if the last two digits are divisible by 4, and these are not. Divisible by 6 if it's divisible by 2 and 3, and it's not. I skipped 5 because it has to end in a 5 or 0. Divisible by 7, we would just have to check. So let's try. 7 would go into 27 3 times. So let me do 7. We're trying 7 here. Just have to check that one out. We'll go into there 3 times, and that would leave us 21. Subtract, that would give us 67, and 67 is not divisible by 7. Okay, so this is not divisible by 7. Divisible by 8 if these 3 are divisible by 8, and it doesn't look like it. We can try 8. Give us 24. Goes in there 3 times. 37. Nope. 9 if this is divisible by 9. Not divisible by 10. 11 says we have to add the even powers, so this would be 0, 1, 2. So even powers of 10, that would be 7 and 2. I would add those and get 9, and then take the odd powers and subtract. If this result is divisible by 11, the number is divisible by 11, and it is not. Okay, so we could keep going and trying bigger and bigger numbers. There are some rules that suggest if you divide this number by larger and larger primes, and if the remainder is a smaller prime number, then it's prime. And so it doesn't look like this number is going to be divisible, break down into primes. It's not divisible by 2, and all 3 of these have a 2. So just by looking at that, we can get to the answer, but I wanted to at least check with those rules of divisibility. So if you want to kind of speed up, you can kind of look at your answer choices. Again, all of these have a 2 in it, so if it's not divisible by 2, it will be prime, but 100 is. So this is 100 to the 12th power. So let's break down 100, and we'll raise all those factors to the 12th, and we'll see what we end up with. So taking 100, we can break this down 10 times 10, and you can do it anyway. It is all going to end up the same. And each of these will break down to 2 times 5. Okay, and then we have 2 times 5, 2 times 5. This is the prime factorization of 100. Okay, so we have 2 2, so 2 squared times 5 squared. Okay, so this is 100, and this is raised to the 12th. And we're going to distribute this 12 to both exponents, so this will be 2 times 12 and 2 times 12. So they give us 2 to the 24th times 5 to the 24th. So that will be our prime factorization of 100 to the 12th power.